We're doing separable differential equations. Separable means you can take the p variable and a t variable and separate them in either side. So the first step is to bring the dt over here. And then because you have dt here, you can only have t here. And as you can see, p is not, p should be over here with dp. Okay, and b is just the constant. So just if it helps you, just think of b as number 5 or something like that. Okay, so to bring this over there, you either have to divide or multiply. Let's multiply 1 over 3p plus b both sides, so that these cancel and you end up with 1 over 3p plus b dp equals to dt. And then you integrate both sides with u being 3p plus b. The left side requires a u substitution, so I wrote this down, and then du would be, if you differentiate this by p, b is just a constant, so it just becomes 0 if you differentiate. 3p just becomes 3 and dp, so that if you solve for dp, you can divide by 3 and you get 1/3 du, right? And the resulting integral is that you get integral of 1 over, we decide to call this u, and then it's 1/3 du, because dp is 1/3 du. 1/3 is a constant multiple, we bring it outside, and 1 over u integrates to ln of u, right? Now, normally you're told to put absolute values, but when you solve differential equations, you rarely need absolute values when you do integration with ln. In fact, I can't think of one example in separable where you require absolute values, so just write it like this, okay, when you solve. If you're solving definite integrals, you always need the absolute value, but here you don't use it, okay? Here, this integrates to just t plus c. Now, you don't put plus c both sides. If you integrate both sides, you only put c on one side. And so the left side is 1 over 3 ln of u, but what's u? U is 3p plus b, right? And the right side is t plus c. And our goal is to solve this, meaning that I need to express p as a function of t, so we have to solve for t. How do you do that? Multiply by 3. And you can just rewrite 3c as a c. And the reason is c is some arbitrary constant, right? This is true for all values of c, so this should also be true for all values of c. Okay, so one thing that you can do is you can just rename 3c as c, because they're just names for some arbitrary number. If you have some arbitrary number, multiplying by 3, you get another arbitrary number. Could be anything. Okay, so we just rename it as c. We still have to solve for p, so let's get rid of ln. How do you get rid of ln? You raise both sides by e, right? And that cancels ln. You give 3p plus b equals to e to the 3t plus c. But what's that? E to the 3t times e to the c. And again, e to the c is some arbitrary value, so I'm just going to rename it as c. Subtract b and divide by 3, and you get c e to the 3t, subtract b, and then you divide by 3. Okay. Now, so this is one way to write it, and you can even further rewrite it as c over 3 e to the 3t minus b over 3, right? And you can just rename this as c, so another way to write it would be c times e to the 3t minus b over 3. Okay. So either this one or that one should be the answer. Okay, let's do the same thing. This seems easier. Multiply by dt both sides. And because dy is here, y belongs to the other side. So we're going to divide both sides by y, which gives you 1 over y dy equals to 9 dt. Then integrate both sides. Integral of 1 over y is ln of y. 9 integrates to 9t, and then you put plus c only one side. You want to solve y as a function of function of t, so you exponentiate both sides, giving you y equals to e to the 9t plus c, but that's same thing as e to the c. Again, rename this as c. So the result is y equals to constant c times e to the 9t. This is almost done, but see, independent variable is t and the dependent variable is y. That means when you have y of 1 equals to 5, that means when t is 1, y value should be 5. Right? So this c should be a constant such that that is true. So when y is 5 and t is 1, you end up saying that you have to solve this for c. So you can divide by e to the 9th power. So c is 5 divided by e to the 9th power. You can bring it back here and you get y equals to 5 over e to the 9th power times e to the 9t, which is the same thing as 5 e to the 9t divided by e to the 9th. And that's perfectly reasonable answer, but if you want, you can even simplify further by saying that if you divide this subtraction in the exponent, so that's same thing as 5 e to the 9t minus 9. Or even further, you can rewrite this as e to the 9 times t minus 1. Okay? So all of these should be an acceptable answer, although this would be the simplest one. Okay, this time, if you multiply by dx, here's what we get. If you multiply by dx, you get 11x times dx That's what you get if you multiply by dx. The dx in the denominator cancels away, but this will get multiplied by dx. Okay, our goal is to separate the dx and dy, so let's move the dy to the other side. And here's the problem. X shouldn't be with dy. This has to belong here. So let's divide both sides by x squared plus 1, square root of x squared plus 1. And then now it's fully separated. I only have x on this side and I only have y on this side. Integrate both sides. This one's easy. That's just 4y squared. And this one requires the product rule. Let me change the color. Okay. So product, not the product rule. It should require the U substitution. So to do this, I need to set u as x squared plus 1, so that du is 2x times dx. And if you solve for dx, that's dx equals to 1 over 2x du. And therefore, this would be integral of 11x over square root of u. We decide to call this thing inside the square root as u, times dx is 1 over 2x du. X and x cancels, and this results in integral of 11 over 2 times 1 over square root of u du. And that's 11 over 2 times 1 over square root of u is like 1 over u to the 1/2 power, and 1/2 power in the denominator, that's the same thing as negative 1/2 in the numerator. And I worked hard to bring it to this form because now I can use the power rule, which says you add 1 to negative 1/2, which is positive 1/2, and put the reciprocal of that. So they cancel, and you end up with 11u to the 1/2 power. 1/2 power is the same thing as square root, and u is x squared plus 1. Okay, so that's what we get, and we have to put plus c on one side. So here is what we get. 11 times square root of x squared plus 1 plus c is equal to 4y squared. Okay. Now, let me delete this part so I can continue the calculation. We're not done yet because I still need to make sure that y of 0 is 9. Y of 0, 9 means that when x is 0, that y value is 9, right? So when you have this equality, when x is 0, y is 9, which is 11 plus c equals to, let's see, 81 times 4, 324. Okay, and then you subtract 11, so you get c equal to 313. So we now have a solution that satisfies the initial condition. So what I did was I just took this and replaced c by 313. And this is still not done yet because you have to you have to solve for y, right? So I'm going to square root both sides, and you get 2y equals to plus or minus square root of 11 square root of x squared plus 1 plus 313. However, although it's usually plus or minus when you solve for y, if you choose the minus, it's not going to satisfy this initial condition because y has to be positive, right? If y is 9, that must be positive, and it can't be if you have a minus here. So although this should be there if you were solving an equation, in this case, after solving it like this, you have to throw out the minus case because it doesn't match the initial condition. So you end up with 2y equals to square root of 11 square root of x squared plus 1 plus 313, and then you divide by 2, and the answer is this complicated thing. Okay, let's go to the next question. Next question here is, okay, so I think I want to isolate dy dx, and then you always have to multiply by the denominator when you have this to separation. Okay, so we're trying to separate dy on one side, dx on the other side. But this is trickier than the other ones because, see, what's wrong, what shouldn't be here? It's really, it's this thing right here, right? That's the bad one because y should belong here. The problem with this is you can't just divide by y because if you just do, then you have 8 cosine x, which will still have, I mean, if you just divide both sides by y, then you get 1 over y dy, but it'll be 8 cosine x divided by y minus 3 cosine x. And that's bad because although you succeeded in getting rid of this y, now y appeared in some other place, so that's not a good idea. So instead, what do you do? Well, after closely inspecting the right side, you realize that you can factor the cosine x out. Then it's a lot easier because I just need to get rid of y, so I just divide both sides by this. So just multiply by 1 over 8 minus 3y. And these cancel, and now the right side is completely free of y, and here you have y. So that's what you have. 1 over 8 minus 3y dy equals to cosine x dx, and once you have that, you integrate both sides. Integral of cosine is sine x. Integral of this requires some U substitution, so let's do that. Set u equals to 8 minus 3y. du is 8 differentiates to 0, negative 3 differentiates to negative 3 dy. So after dividing by negative 3, you get dy equals to negative 1/3 of du. Right? And then this becomes integral of 1 over u times negative 1/3 du. Negative 1/3 can be pulled outside the integral. And as I explained before, you can just write ln of u. You don't need to put absolute value. And that's ln of 8 minus 3y. Okay, so you put these two together, and the outcome of this calculation is that you have negative 1/3 ln 8 minus 3y equals to sine of x plus c. Yeah, we're almost there. We're still not there because we first have to figure out the value of c, and on top of it we also have to solve this for y. So let's hang on. Let's see what we can do. Let's get rid of this side. Okay. So this means when x is 0, y is 7. Actually, let's first solve for y, and then let's worry about this later. Okay. So multiply. The goal is to isolate y, so I need to get rid of this negative 1/3. I multiply by negative 3. So it's ln of 8 minus 3y equals to negative 3 sine x, and then negative 3c, but we renamed this as plus c. And it's just some arbitrary number, so you can do that. Okay. All right, and then we exponentiate both sides so that e and ln cancels, and you get 8 minus 3y equals to e to the negative 3 sine x plus c, and that's e to the negative 3 sine x times e to the c, and that's just a constant, right? So here's what we have: 8 minus 3y equals to c times e to the negative 3 sine x. And then move 3y to the other side, move this to the other side, so we get 8 minus c times e to the negative 3 sine x equals to positive 3y, and then divide by 3, and we're almost there. Y is 8 minus c e to the negative 3 sine x over 3. But we still need to figure out what c is. So let's erase this part. Now we plug in 0 and 7. So when x is 0 and y is 7, 7 should equal to 8 minus c times e to the negative 3 sine of 0 over 3. Sine of 0 is 0, so this is 0, and e to 0 is 1. So this becomes 7 equals to 8 minus c times 1 over 3, which means 7 times 3 is 21 equals to 8 minus c, so c must be 8 minus 21, which is negative 13. So plugging that in back into here, you end up with y equals to 8. Negative 13 is plus 13 over 3. And that's the answer. Okay, another very similar question. Multiply dx both sides. And let's rewrite this as 1 over e to the 2y. Okay. Then it becomes clear that in order to move this to the y, I should multiply by e to the 2y. Right? So that these cancel, and you end up with e to the 2y dy, x minus 3 dx, which is fully separated. X is in here, y is there. Now you integrate both sides. Set u equals to top 2y. We need U substitution to do this integral. Du is 2 dy. If you differentiate 2y, that's 2, and then you attach the dy. Therefore, if you divide by 2, it's dy is 1/2 du. And then dy is replaced by 1/2 du. 2y is replaced by u. Pull the 1/2 out. Integral of either u is either u, which is 1/2 e, and then u is 2y. Okay, so that's what we have, 1/2 e to 2y. Let's not put the plus c here. I want to put plus c on this side. X integrates to 1/2 x squared. -3 that integrates to -3x. So that's the, if you integrate this, you get this. And now we have to solve for y. Let's do that. Multiply by 2. And we can just rename this as c. Okay. Take ln. You can't take ln term by term. You have to be to the whole thing. Okay. You have to be careful here. Okay. ln and e cancel, so you get 2y equals to ln of x squared minus 6x plus c. So you get y. Well, at this point, let's try to find the value of c. Okay, so here, when x is 3, y is ln of 2. So let's figure out what that would give us. Okay, so you have, so maybe over here, I might do that calculation. 2 times ln of 2 is equal to ln of x is 3, so 3 squared minus 6 times 3 plus c. So that means 2 times ln of 2 is equal to ln of 9 minus 18, that's -9, right? It's nice, it would be nice if we had just ln of something equal to ln of something, that then whatever that's inside would be equal. And there's a perfect thing to make it look like that, which is what I call jumping the frog over the log. So here's the log function, and the number in front of the log can jump over the log like that. So you have ln 2 squared equals to ln of -9 plus c, and now it's doable because this must equal to what's inside, right? So these two should be equal, so we have 4 equals to -9 plus c, which gives you that c must be 13. Okay, so once we get the value of c, we can now write down that y is ln of x squared minus 6x plus 13. We know that value of c is 13, and then you can divide by 2. So that's how you can do this.